you give them a final, like the vision, vision of the end product is supposed to be this big, but its mock-up, it doesn't work. It's just a shell. And then you also give them, the larger one. Okay, so this is where we're at. This is what we're aiming for.
I want to give a quick introduction to Leo now before he does this short presentation. Leo is the founder and CEO at Lumeo Technology, which is a Swedish hardware startup. And it's about wearables, but not only wearable electronics, but also other things. And yeah, Leo, the stage is yours to give us a presentation about your work. Thank you so much for being with us.
Thank you so much, Thomas. It's a pleasure to be here. Super happy. So I'm Leo, founder and CEO at Lumeo Tech. Like Thomas said, we're a Swedish hardware startup focusing on empowering wearable electronics and wearable hardware. Now, personally, I have a background in production development and industrial design. A couple of years ago, I jumped headfirst with zero experience into the startup world with my own company, and it's been an amazing journey so far. And I had the pleasure of taking a wearable product from idea to the markets back in 2017 when the company was founded. We sold about 45,000 units, had to deal with a lot of challenges, copycats, and much more, and made enough mistakes along the way to become, well, a bit less stupid today. And so what do we do at Lumeo Tech today? Well, we want to enable an unmatched freedom in how users can wear and use wearable electronics. And the first solution that we've launched is called Lumio Loop. It makes it possible to attach basically anything, anywhere on any fabric. So imagine that you have a sensor or, for example, a light, and you can just push it anywhere on a fabric, twist, and it suddenly stays in place. At the same time, you can remove it and put it somewhere else. It's almost like magic, but not really. So please let me show you Chevron Slides and show you how it works. Right, so I hope you guys can see the screen right now. Now, these tiny modules on the back side grabs onto the fibers of the fabric, and it creates a temporary seam between the hardware and the soft fabric. Now, in this example, we have Lumio Lite. It's a product that we're launching this autumn through distributors. And in the front, it's a very normal but strong LED. Could be any product. But with Lumio Loop on the back side, it gets superpowers. And you can wear it on your body when, let's say, running, when camping inside the tent, in tight spaces with a magnet on the side, and all these possibilities in one single compact light made possible by Lumio Loop. But the journey to get here has been super challenging. And how did we get here? Through the process, the development process and everything. It's been quite a challenge, and I look forward to sharing some of my experience with all of you today. So thank you. That's a bit about me.
Thank you, Leo. Super interesting. Looking forward for the conversation. Great, thanks. Yeah, Charles. Charles is also with us. And Charles Gayot. Sorry for...
I'm French, so...
Yeah, okay, sorry.
Charles-Henri Gayot, if you want to try in French.
Gayot, okay.
Yes, you can call me Charles. That's perfect.
Charles, yeah, that's how I know you. Charles, he's founder and CTO at StepUp Horse. And he also invented or is working on a series of wearables that are able to measure accurately breathing with animals, but also with humans. But in this company, you're focusing on horses, which is also very interesting when we're talking about prototyping. So thank you also for being with us, sharing your time with us. And yeah, the stage is yours.
Well, thanks a lot for having me. It's really a pleasure to share my journey, I would say, on that, and crossing thought with Leo, because I know that that's going to be very, very interesting. So quickly about me. I mean, I'm working in Denmark right now. It's been 6 years. I'm in Denmark, almost as long as I've been working in the startup world, and yeah, mostly everything from building different products and building different products and trying to bring them to market. That's basically what I try to do. I'm an engineer. I'm usually more on the electronics and the software side, so quite complementary with Leo. And our mission in in the StepUp, in all the StepUp companies, to kind of try to put breathing to make it as simple and as accurate to measure than what the heart rate is today. Breathing, when you exercise, when you move, there's a lot of limitation to measure accurately breathing, especially for reasonable cost, because wearable most of the time should be somehow cost constrained. And that's more or less what we try to develop. Very quickly to show you a little bit the product that we're doing. Yes, so what we started with StepUp Solutions, which is kind of the big umbrella, and the first product we tried to do was for sports people. We thought it was extremely interesting to do breathing in sports, and I mean, it is interesting in many aspects, from a technical point of view and a scientific point of view. When we went to a more, how can I say, market point of view, it's a little bit harder to actually pierce there. So let's say on our page, that's kind of how it looks like. It's something for teams, for professional, to measure breathing. We always combine with other type of sensors so that we have a full solution with heart rate. You can actually see, I mean, this is not actually behind me the strap that we are using for sports. It's for our healthcare application, which is basically this one. What we do is to help people with chronic pulmonary disease like asthma, like COPD, and to try to make their daily life a little bit better by trying to prevent exacerbations. And it's quite complex because it's building everything from the hardware to some quite powerful AI platform that try to get the right input to predict when the patient is going to get worse. And let's say where it's interesting is that we really master all the development chain on that, and we can easily prototype new feature, because we know that if you want to add a feature from a hardware point of view, from a software point of view, and in the end in the model, we can do that extremely quickly if we do everything in-house. And finally, the product, as you say, is from StepUp Course, is something that we're going to test it's quite exciting, by the end of summer, so in a bit more than a month now. We're basically finishing all the manufacturing of the first series, and this idea is to really monitor horses to kind of prevent overtraining, and in the end is really to avoid what is called horse wastage, which is basically the fact that horses get injured or worse, die on the racetrack. So that's kind of a very interesting purpose of measuring breathing and other vital parameters to make sure that doesn't happen. So yeah, I think that's it, a quick overview of what we do.
Nice. Yeah, thank you, Charles. Super interesting. And I think, the animal sphere has not been targeted so much, as far as I know, with wearable tech. So this is new and exciting. Thanks. Interesting. So let's just dive in from the beginning. Like let's define quickly what a prototype is in your opinion, because Leo, you're more from industrial design, and Charles, you're more from electronics. And I think let's find out if you have the same perspective, the same definition on the topic. So maybe Leo, if you want to give us just a short definition of what a prototype means to you, or what it means.
Right, absolutely. So like in my company, we do a lot of prototyping. With every single new client that we get, we do a new prototype because the solution is adapted to their product. So for us, a prototype, it's a way of visualizing the vision, and realizing the vision. it's very different when you have it in your head, even in the computer, and actually having the prototype, you know, in your hand. For us, that works a lot with hardware.
Yeah. So okay, that's from a design perspective. You have a prototype in the computer and then in the hand. I think that is also very important for wearables because you touch them all the time, most of the times, and especially with your product. Charles, does this design aspect play also a major role from your perspective as a CTO, or is prototyping more technical issue for you, a technical thing?
Yeah, I would say it's both. I mean, the way I see prototypes, it's basically trying to validate everything that is on the way. So it's a way primarily to decrease risks about everything you're developing. So to make sure that if, of course, it works technically speaking, if that's what the ultimate user customer wants. And I would say it's not only, it's not only one prototype. What we quite often hear about the lookalike and the more functional ones. But even if we go more in depth, from our side, we develop a lot of small pieces of electronics just to validate one specific thing, just to make sure that when we launch our next batch, we don't screw the whole board because just one little thing is not working. That's also an experience from the past that this kind of thing can and will go wrong when we actually do them. So yes. Mm-hmm.
Mm-hmm. Okay, interesting. And so you said, both of you, or Leo, at least you said there's did I get it right? There's a design prototype and functional prototype, or like, because your product is very miniaturized, right?
Yeah.
Can you give us a little bit more insights through how you went through the prototyping process with this invention? Did you start with a bigger version, and then also did you already prototype your final vision, or how do you deal with the technical parameters and also your design wishes?
Right. Yeah. It's very, very complicated, I would say, like with all physical things, all physical like prototypes. A lot can go wrong, and I think I agree with Charles. I mean, we do a lot, like Charles and your team does, breaking up the functions into smaller parts and then test those individually before putting everything together. That way you can quickly verify what works and what doesn't work. Now everything starts, in the mind with an idea, and doing the prototypes, it either confirms the idea or more importantly, tell you that, well, that idea sucks, that it won't work. So I mean, it's been a long process, and we've done different approaches. For example, I actually got a few prototypes here that I can show you.
Let's jump in this. Yeah, show us. That's super cool.
Yeah. So I'm gonna start by showing the first product that we launched back in the days, and it started with this. This is a cardboard cut out of the cardboard, and it's not really, obviously not functional, but it's just something that you can hold in your hand and kind of pour your ideas and pour your dreams into. You hold it in your hand, okay, it's gonna do this, maybe, and then you take it from there to try the different parts. So we got from here to 3D printing using, was a very old 3D printer. Mm-hmm. Really rough prototype. It looks really ugly, but the important things, did it work? Well, of course not. It didn't work. This idea was shit. So that one, we confirmed that didn't work. But through the process of, I'm guessing like 500 or more prototypes, we arrived at the actual product in the end. And I think it's very important, like Charles said, to test it individually and define what doesn't work and how you move from there.
Okay, let's just stick with it one moment longer, because, okay, you have this non-functional volume model.
Yeah.
But then I think what people might ask themselves now is, okay, how did he make it to the product? Because, how did you know how small you can go with your technology? How did you find your way to this final functional product from a 3D printed volume? what was the challenges here, or how did you proceed then once you had the volume?
Right. So we use a lot of different processes basically. I mean, there are limitations with every process. Cardboard, obvious limitation there. FDM, 3D printing, limitations with the resolution. And how do you get something, you know, good enough? If you try with super small right away, it's very hard, and you can fool yourself with, you know, something's going wrong, but you think it's something like that, but it might be just material or smaller things. So we always like oversize everything. So here's an example of the latest, the Luma Loop detachment system, right? So we got it from this one into this one.
Wow.
And so how do you go from actually like this one into this one? But by this time, we already had good 3D printers that could print, but you need to test the function. So you start with super large, get the basic mechanisms and the design like correct. And then we kind of like push the limits, try smaller and smaller. And then, also keeping in mind the manufacturing parts in the design process, like what will it be possible to do in actual manufacturing? What's the minimum wall thickness and so on.
Mm-hmm. Wow. And you keep it in mind during the prototyping process. You also need to know about what it is needed to manufacture the product in the end. Yeah. Okay, cool. Thank you. Charles, you are also working in the health industry and also in the consumer industry. I think when it comes to prototyping, could you give us a few insights on, let's say, how you define goals for a prototype, or how do you involve your stakeholders? What is actually, how do you write your own briefing to make a prototype?
And that's, I mean, that's the hard part. That's for sure. I mean, it's incredibly hard to know what is what is the prototype? What should it look like? Because when we work with customers, or even most of our stakeholders, is that they don't understand why what we are showing them doesn't. I mean, if it's a lookalike, why it's not functional, or even worse, what we are actually delivering them as what we would be like a final product or an MVP is actually like, no, I'm not going to wear that. You know, that does happen. And I mean, we actually had it in our when we did the sports one. So if I can, my side as well is that I say at some point, we are kind of data driven. So let's say from our side, when we develop those wearables, is that the fact that we can miniaturize it is we kind of know that we can. So it's not that much a design challenge. It's just that the more we miniaturize, the more, let's say, electronics development is needed, the more time we are going to spend on that. So we kind of have to stop at some point. And what we did actually at some point is that we needed to collect more data. So we are data driven. We need to make sure that it's not only about customers. If the future user is going to be happy, it's also to make sure that the data we collect is useful and build the best thing. So that's kind of our strap. So it's orange because, well, that's our sports company color, but that's kind of how it was looking. So that's what we did. And as Leo said, even the design is very, very well oversized. I mean, completely oversized and thing, but at least it works. There's several layers. There's a battery inside and everything, as you can see. And that's pretty much all our feature. But I mean, let's say we can't really sell that. I mean, we had a hope that maybe some researcher could actually use it for his research or for his or her research. But it didn't really happen in the end, also because, as I said, that's typically one design that has been hit by a design flaw. So that's kind of why it was a bit hard to fix in the end. So made it really complex to use for the user. But yeah, that's kind of what we did in the beginning. But that's already quite an advanced prototype for what we can do. If the very first proof of concept that we did was basically, and I was able to find it. I didn't even know we had it. That was this. So that was okay. That even fell. But yeah, this is the strap that we had with our sensor. That was kind of we're using a new type of sensor technology, and that's kind of our secret sauce. And this was the first box, and with that, we proved that it worked because this ran a semi-marathon, and with one that was hailing like insane. So it was electronics with a lithium battery, basically with something that can catch fire. That was one, as someone that was in a storm, it was a real tempest. Well, it didn't explode. It saved the data until the end, and we were like, okay, that was cool. Let's move on. And yeah, wow. Let's say data-wise, that was good. That helped us to rebuild that database so that we can see that, okay, our product works. So, you know, when we look from a scientific point of view to try to convince researcher, in a way, that was good enough. If we took to consumer, and then, yeah, today we are also developing for a more complex product for healthcare stakeholder. That's a bit outside of the work of breathing-based wearables. We kind of have to make everyone happy. That is the doctors. We're going to say, oh yes, but our user, I mean, the patient can't really have it like this, because I mean, if it glues too much, it's not good, because it may impede a little bit the vein that is there and things like this. And it's kind of the project that go through way more iteration than what we think, because in the end we're like, okay, we can do that. We brainstorm, we do it. We try to make a prototype, we show it, and then we're like, yeah, but no. And then we need to reiterate again. And I mean, this project is typically one project that really pushes all the sensors inside at their boundaries. And at some point, you know, it's the trade-off about what's technically possible or what is going to be technically reliable, which is even worse, because it needs to be precise enough, and what is actually going to be design feasible. And that's a very long talk. And especially when you are a subcontractor, you are not in the position of strength where we can say, yeah, we stop here. You can't say that. And you know, that's the difference between being really a subcontractor and actually doing your startup, where you have the right to say, yeah, we can't do better, we stop here, we try to commercialize it, and yeah, hope for the best. Mm-hmm.
Okay, yeah, very interesting. I took away a few things, a few questions that we can talk about. Like, what is let's go into this one, because maybe some people don't know this term. You said minimal viable product. What is a minimal viable product? Also, like, let's also define the limitations of, sometimes you have to stop prototyping somewhere, right? So what makes a viable product minimal, in your opinions? What is the meaning of this? Why do we have this term minimal? Like, because what you showed, Charles, I guess, once it delivers the correct, precise data, I have a feeling like you have demonstrated that it's possible, right? Is that the minimal, like it can be a box, but the sensor works, right? Is that, or do you think you have to go on with prototyping then to convince your partners?
No, I mean, yeah, that's exactly, I think you just asked the right question, is that to convince the partners, and that's exactly who do we need to convince? And that's what it is. I mean, with a big box, we won't convince the user, the consumer. It's not going to pre-purchase the product if we can't show him or her that it's actually going to work, and it's sure that that is going to work. I mean, today, if we look at even on Kickstarter campaigns, and I mean, they ask for fairly high standards in terms of prototyping. They already want to see the product that is going to be pretty much the final size before we actually carry out the campaign. And it's understandable. When we talk consumer electronics, it needs to be at a very high level of progress before it can be called an MVP. And yeah, those very high level prototypes that are lookalike and functional in one box, and that pleases the customer, and that can actually be sold in pre-sales. That's what can actually become an MVP, not before.
Mm-hmm. Yeah, Leo, you also, when you develop the products from your technology platform, so to say, if it's okay to call it a platform with different functions, you said you're prototyping a lot. What is like, do you use these prototypes to kind of advertise or sell this to different clients?
Yeah, so I want to build on what Charles said. Mm-hmm. It's very different when working with consumer products. Currently, we're only working B2B, so we only have companies as customers, not really consumers. The demands and the requirements of the communication is really crucial. And what we do in the aspect of MVP or proof of concept, like how do you actually draw the line? What you explained before, now if you have a big box that does the basic functions, I would call it just a proof of concept, not really an MVP, and not for our definitions. But what we sometimes do when it comes to a completely new product is, so we do a mock-up, right? So we offer two different. So you give them a final, like the vision, you know, vision of the end product is supposed to be this big, but it's mock-up. It doesn't work. It's just a shell. And then you also give them, you know, the larger one. Okay, so this is where we're at. This is what we're aiming for. And of course, I mean, it must be, you know, you must believe that it is physically possible to get it to this small, because some clients, they want it like to the size of a penny and have everything inside that. That's not possible. But we're pretty straightforward and say it right away. So we do like, you know, the mock-up, the rough proof of concept prototype. And then once you get closer to, like closer and closer to what you are actually aiming for, something that they can actually use and test, I would call that one an MVP. It could be 3D printed. I mean, like all this, everything that I've shown today, basically, that's 3D printed. And you can get very far with 3D printed prototypes. Yeah, as long as you can get the electronics down to the size. So, I mean, from my perspective, I think the communication is the absolutely most important thing. No matter who you're working with, whether it's a company or the consumers.
Yeah, very good to know, because I think if you found a startup, you have to evaluate if the idea is doable for yourself, but also for other parties like investors or your customers later. Yep. That's interesting. Leo, you also shared some insights to us in a previous conversation that we had about like when you design for manufacture, and also you went to China. You said it also that you produced over 50,000 pieces of another product before. So can you just give us some insights in what it means to take your product to China to go to production? Because I guess you have a prototype, possibly 3D printed. I guess there could be some problems when you want to go into mass production. Or you already mentioned that you have to keep in mind the mass production factor, but maybe you have, I don't know, can you just share some insights?
Right, so in our case, we had to have, you know, a very quite complete, like getting past the MVP stage and have an almost finalized, you know, product. But we started to talk with manufacturers much earlier than that, because that one, that was the first journey that we learned a lot. We didn't know what worked, and we actually went to them. We didn't tell them exactly what it was. Like, so this is the part kind of what we wanted. Can we do it? And well, the first manufacturer said, yes, we can technically do it, but it will cost you a fortune because that's a really bad way of doing things. And so, okay, what's a better way of doing it? You know, or why doesn't it work? And by asking this, you know, why doesn't it work? Eventually, you will learn a lot and land on something that, you know, may work better. And that was our experience with the process. Now, for me, I had to, you know, go physically over to China to get these parts done. I mean, I was born in China, but I came to Sweden when I was 5 and grew up here, so I knew like nothing, not the language, nothing in China. So going there and you know, trying to find the right partners to work with was super, super hard. And I think what you need to keep in mind is to, you know, first of all, not reveal too much right away. Obviously, I mean, that will get your products copied, you know, very quickly. And so we did it like step by step, and then but sooner or later it will be on the market. So I think by understanding the manufacturing process and implementing steps into the design process, you can actually make it so much harder for someone who doesn't have kind of like specialized tools or so to make it. And that's one of the things that could give you an advantage when producing, you know, a physical product. And these, I mean, these tools or these special implementations into the design, it could be, you know, electronical, but it could also be, you know, very physical, you know, a part that's super hard to like manually or it gets into one piece. In our case, there was a lot of magnetic parts, so we took advantage of that and made special like fixtures, special tools in order to for our manufacturer to be able to produce it very quickly. And so we had a good head start. Sooner or later, copycats, they would catch up. And that's what happened to us. I mean, we during, I think it was not even a year's time, we sold like 45,000. But then copycats started to come, and we had to try to deal with them as a small company and with very little experience. That was very hard to do. Yeah, but like after all these journeys and learnings, we know how to prepare before that happens, and how to hedge against that.
Great. Before we talk about what you can do to avoid that, I want to ask Charles, because the same question, but for the electronics part, because let's say most of the people, maybe they prototype with Arduino boards or something, I don't know. How do you make a step from this kind of prototype that just shows the function towards a design for manufacturer? Like where's the transition? Do you consult also your manufacturers, and have you also been to China? Like, can you give us a few insights into your experiences here?
It's this whole thing about starting to design for manufacturing is a very huge step, and it applies as well. So more on the software side is that from our side is that the big box I showed you was running on a small Arduino chip. Today we are running a code that is extremely similar in the way that we're still, for all our scientific testing that we've done so far, so that's for healthcare, that's for horses, that's for sports, we've always been running an embedded code that is Arduino based. That's at some point we need to stop, and right now we're exactly in that process of going from Arduino to actually native C code that is energy efficient, that is robust, that is everything that's actually needed to have a final product. And that's expensive. That takes a lot of time. It's a huge work. A product like ours, where without going into the details, but we have a lot of different sensors, a lot of different communications, and it's a long process. And that's just talking about the software. In electronics, design for manufacturing today is a game of trying to find available components. As I said, we're trying to push our new product that we want to test in 1 month, 1 month and a half. And I was, let's say, casually checking. I usually check, and that's good practice from the moment you start prototyping with electronics, and there are some components that you will need for and you won't be able to replace them in your design. Use some kind of bill of material tool on one of the big suppliers' websites, so that you can always track the availability of what you need. Because I just got caught, like I checked a month ago about some core components we are using. One of them, for instance, is the one for the heart rate measurements. And I just realized that it was not installed in the official suppliers. And that's the kind of thing that, you set up an alert system to make sure that doesn't happen. I know that already half of my components, I sourced them the moment I saw the stock was low. I basically bought the last 20 chips of I think it was our main processor, because I saw it was the very last available in the official suppliers. And right now, that's kind of more what it is. From our stage, we're still on fairly small scale. Our next production should be, it's going to be about 25 units. So it's small. It's just, we still need to validate some things, but we need a complete design that can go into the hand of the users. So it needs to have the size that they need to be final. But that's, there's going to be a lot of things there. Regarding the design itself of the electronics, there are some details that you need to pay attention. Things like panelization, all these kind of little issue that you can have to make sure that when you manufacture everything, you can actually remove all you can disassemble the units you are making, so that you can put them in the assembly process. It's a lot of details. Can you learn it by yourself? I would say, if you have an electronics engineer in your team, that shouldn't be an issue. But it's kind of the thing that you also need to pay attention to. Yes. Mm-hmm.
Cool, thank you. You mentioned that, yeah, you want to give it to the hands of, you make a small series of items, and then you give it into the hands of the customers. So that brings us to the topic of testing. And I think, Leo, you had the idea of defining the process into internal prototyping and external prototyping, right? And maybe you can explain these two, this idea of these two phases and where we put this testing into. Is it a back and forth, or is testing in the first phase? Or can you explain a little bit, please?
Right. So, I mean, I think in the testing phase, what you want is to get correct and reliable feedback and get the data that you need in order to improve your product or improve the process itself. And that's why I think it's good to divide it into internal and external, where in the internal you basically test like the basic functions. I mean, does it work? Does it not work? How does it feel for me? But I think the internal testings should be quite short. This larger focus should be on the external. And why separate that? Because why not just give it something to the external end users right away? Because that can really mess up the feedback that you get if you haven't tried at least the basic things and don't have a clear goal or what you want to have answered from external parts. You give them, they would complain about a lot of things, tell you a lot of feedback, things that may not be like the actual problem, but you really want to get to the root of the problem. So do the internal testing. Once you feel confident about that, which should be a very short time, give it to the beta testers, your customers. Probably your customers will have an internal process as well. But just get it into the hands of people who who's not you, because a lot of times for us, I mean, we're working with it every day. We know exactly, we take it up, we know how it works, we know everything is so clear to us. But once you give it to someone who hasn't seen it, hasn't touched it before, they will react very differently. And so you can do it with customers, or if you're a large company, you can hire some focus groups and different types. And there's so many ways to get testers. So I think separating these two, making clear what needs to be tested in each stage, and bring it back, do the changes, throw it back out to see how it does.
Interesting. And okay, so yeah, it's a good point, because sometimes, in I'm a graphic designer originally. They say you have to kill your darlings. Don't fall in love with some design that makes you blind for things that might be improved or issues. So how do you make sure that you collect right feedback from the people who test it? Is there some standards? Is there something that people can look up in the internet? Or is it something that you think about before you give it to them? Or is it more organic process, feedback loop, and you give it and you say, is it better like this or like this? Do you have A/B testing, different form factors? Right. What is a good practice example from your practical work?
I think when working with hardware, it's A/B testing is good, but when working with hardware, it's very, very hard to do and very time consuming to do A/B testing. It's not like a website you can throw out and see which one gets more clicks. And the feedback from different iterations will be very different in many cases. So I think you need to start thinking about it in the beginning, right at the idea stage. For example, you come up with an idea. It's obviously to solve some kind of problem, right? And you go through a process before prototyping and everything. You go through a process of actually verifying, is there an actual need for this product I'm making, right? And so for the internal criteria is, okay, so these things that I've defined, that would help this person solve a particular problem. Does it actually do that right now? Yeah. And if it's no, it's obvious, kill your darling, go back to the drawing board, do something about it, and kind of iterate through that. Once you have something that actually works with your like core theory, I think you should stay very open. Like throw it out there, maybe like teach them once how to do it, like in the first stages, but then be very open with the, you know, with the feedback or with what you ask. You know, the mom test is a very good way of doing it. It's a book, highly recommended. And I mean, that's one of the ways of doing it, throwing out there, asking, okay, so how did you use it? Did you actually use it, or did it just like you've had this one for a week? If you use it for one day and then throw it in the drawer, obviously something is wrong, and so on. Yeah. And be open to take in all the criticism. And once you have taken it in, because you will get a lot of different, and people might say the same thing in different ways. That's why it's very important to have the process of, after collecting everything, sit down with your team and actually analyze it. Mm-hmm. What does this mean? How does this translate to in terms of function? Yeah.
Super nice. What's the name of the book again, the title?
The Mom Test.
The Mom Test.
I think
maybe. Yeah, I can definitely recommend it. Sorry.
Yeah. Okay. Maybe Leo, if you could write it in the chat, the title name, if people are interested, they can have a look. Thank you. Thanks so much. Charles, since you're working with horses now, you have been working with humans, but also with horses. What makes animals different when it comes to testing? Like, or do you prefer working with animals, or is it better to work with humans because they can give you real feedback? But on the other hand, maybe a horse is very true, you know? I don't know.
Well, that's. I mean, if I can share a little anecdote, is that when we tested our very first prototypes on horses, so it was. Let me just get it here. Is that it was? I mean, we actually took our straps like this for humans, and what did we do? We put 2 or 3. I don't remember. Yeah, I think we put 2 that we put because it's a hook. So we basically put 2 in a round, and we put it around the horse. That was actually our very first horse. Proof of concept kind of, and then location wise we had to make some changes. So what we did is that we put 2 straps in the end. So that's actually a horse strap, a heart rate horse strap standard on which we added our sensor. We can't really see it because it's black on black, but it's actually in the textile. And there was one in the front, one in the back. The problem is that if you put it on the back of the horse, it actually slides even more in the back until at one point it starts to hit the genitals of the horse, and you don't want something to touch the genitals of the horse because the horse becomes crazy. So that's kind of something we had to do some changes on the design, or at least for that very early data collection. So that was something we learned with horses. However, we are working with race horses, and the difference between, young horses or normal horses and race horses is that the latter are extremely disciplined. They just obey, they don't mind. So we don't really have a comfort feedback. However, what we notice is that the users can be, the trainers or the riders, they are extremely protective of their horses. So it's a bit of a paradoxical situation where they push their horse like crazy to almost bring them that close to just killing them, because horses just obey to what the people are saying. However, when they want to put a strap, they are going to say, oh no, we don't want to tighten it up that much, we're afraid it's going to press on the horse. And you're like, yeah, but if you don't tighten it up, it doesn't work. It's going to move everywhere, and that just defies the purpose. So it's it's kind of the thing, but it made us increment in the design, and that's why we came up with that large belt that can't really be put wrong. It's much more straightforward. You can't really not tighten it enough because, it's going to be more annoying than anything, and that's kind of how we ended up in our design. But that's kind of the thing that makes us different, is that it's true, we have 2 users to consider at the same time, the animal and the human.
But you started with a prototype for humans, and then you adopted it to horses, right? And yes. Did you have, how did that happen? Did you have a connection to horses, or how did you come up with this idea? Because it's extraordinary, so to say. Yeah?
The thing is that I think it was two years and a half ago, we kind of wanted to look at new horizon in what we could do with our technology. and one that really hooked up was the horse one and the race horse one. One of the main reasons that we heard about is that there are several disciplines in horse, so in professional horse racing. I mean, so in professional horse riding, and one of them is endurance, and also race horsing. And for both of those disciplines, there are a few horses that actually die on the racetrack or shortly after. One of the reasons that today endurance, I think it's endurance racing or race horsing, is not directly in the Olympics, is because they're afraid of the public backlash. Is one of the horse actually collapsed on the field, and right now the horse well-being is a main concern. And in this year, I think it's the Swiss or the Belgium Federation, that's actually one of their priority, and everywhere in the world it is becoming important. So that's why that's why we saw horse as a huge opportunity there, and also technically speaking, our technology was just perfect for that. So that's why it was a very good match.
Great. Like we don't have so much time left, but there is two things I wanted to talk to you about. First of all, Leo, we still have the question open. We're jumping in topics a little bit, but thank you, Charles, by the way. How do you prevent yourself from being copied, and possibly what do you do next once you get copied? I wanted to talk about that as well before we go to the end race of our little horse race.
Yeah. Right. Preventing. I'm not sure it's possible to actually prevent completely. That's very hard to do. I think so. In our case, what we have learned, the best way is to be better, like competitive, like have a competitive advantage against them. So copycats, they don't compete with innovation. They don't compete with quality. They compete with price, right? And so number one, make sure you think ahead about how to make your product as cost effective as possible to produce, right? Boil it down as much as possible. Now, of course, I mean, if you cut corners and reduce the quality, you can always get it to lower. But then in our case, I would say don't focus on trying to cut off the copycats. Rather try to cut off their sales channels. And that could be, I mean, it could be on like Amazon, on Wish, on Taobao, Alibaba. It could be on a lot of different places. They've gotten quite good actually, taking that down different stores using selling counterfeit products. Still a lot. I mean, especially in the consumer market, still a lot of counterfeit. Yeah. But once you have your idea and your products like kind of complete, or you know what you want to do, I think a patent is always good to have. Now it really depends on how strong the patent, and then of course some people say, oh, in China it doesn't matter or so, but it actually does matter. I mean, having a patent is better than not having a patent. And if you have the patent and all the trademarks like registered and done, you can take what you have, these intellectual properties, go to these larger platforms, so the sales channels of these copycats, and try to handle it that way. So that's one way of doing it. Another way, which is also like one reason why we switched strategy to working only with companies like B2B and putting our technology into like our existing products, is that alone is not always strong, especially when it comes to a small startup, right? It's you against all these copycats or all their distributors and so on. It's really hard to do. So the other approach from us was to okay, great, we know that we got this technology that can actually like work in a lot of different products, and it can change a lot. So we partner up. We partner up with other people, and at the end of the day, we do have the strengths of both parties in that case, in order to figure out how to handle eventual copycats. And one more thing that we learned along the journey was so design patents. Usually they say, yeah, I mean, if you have a design patent for something round, the copycats, they can just make something square and get around that. Yes, they can, But then if you don't have any protection for that, they can actually apply for your product and then like block you. So that's also like I think it's better in some countries, but yeah, that's also a huge risk that needs to be considered. But the bottom line, I mean, plan for the copycats early on in the process. Don't even try to fool yourself that they won't be, or well, it depends on what kind of, like if you're into like deep tech, super advanced technology. I mean, you got the competitive advantage in terms of innovation, sure, absolutely. But think about it early on. Try to get an advantage somehow. And also one more thing that we kind of like switched to when producing the new like core technology. Very simple to produce, only 3 parts. Probably like companies or copycats may be able to copy this, but if they try to copy this, or if they copy this, they would never be able to copy our connections with like the partners that we have, the brand that we have built up, but also we in the design process, we made this possible to automate, have this done by a robot fully automatically. We haven't done that yet, but it's possible to do it. In turn, would make it so much cheaper for us to produce it, and so we would also get an advantage when it comes to pricing. Yeah, and yeah, so I think those are the basic.
Yeah, very super interesting, Leo. Thank you so much for sharing this.
Can I add something super quick?
Please go ahead.
Yeah, it will be quick. It's also about, I think, providing the kind of the experience for the end customer. I mean, at least ours, where we are a bit more, I mean, we are B2B with horse trainers, for instance, but it's still in the end, it's a final user who is not a specialist in electronics or in wearables. It's also this idea of being able to provide an experience. I mean, in our case, we can think that, okay, if someone copies our hardware, what will he need to do? I will need to kind of copy the design, so find our sensor technology, first of all, replicate it. But it's also about, okay, he has to find he has to build, let's say, kind of the network about that relationship with the trainers. And that's also why for us going for more, let's say, elite markets is much more interesting than going for the mass market. Mass market is usually not, I mean, it's very hard to be worth it. It's better to go into what's premium, where we can price it, where the pricing does not really matter about the product, where the pricing actually matters about the experience you deliver in the end. That's the thing. You can look at the competitors if there's any, and you're like, yeah, sure, I'm going to price the same because that's what they do. I know that for that amount I need to provide this level of support, and but then that will cover, that will be, yeah, I mean, hopefully more than 10 times the actual full price of building the product. And also that's also something we didn't talk about when prototyping. It's all this question of cost. I mean, I'm deviating a little bit, but I mean, prototyping from our side, we did it extremely cheaply. I mean, to be honest, I didn't even know it would be possible to prototype so many things for that little. I mean, we've been manufacturing PCB and everything, and I think our first actual prototypes, so not the box that you saw, but the first PCB custom electronics board that we made, it costed us nothing. I mean, we are like €5 for one board plus what 20 euros of components. We sold it ourselves to be able to switch between different components to adapt and everything, and that was just nothing. So, and that was our first custom wearable that we could actually put out. So that's also something we need to keep in mind. But when we are at the stage where we are, I mean, we have our bill of material, we know how much everything is going to cost, and we keep that under very good scrutiny. And yeah, and of course, in the end, there is the assembly time that is always the unknown that we will see when we actually go for full design for manufacturing.
Nice.
So
Charles, that's super interesting. I wanted to also ask you something about software when it comes to copycats. Does that play a role, or the software part? Because you're also developing firmware software. Is that something crucial when it comes to prototyping, or is it something that's just there and it's not so much of a topic for you?
let's say there are different levels here in what we can talk. Is that when you think about what is possible to reverse engineer, is that, let's say, the firmware that you actually have, if you are not, I mean, we're not quoting any name, but if you are not a big automotive company that want to save cost everywhere, you're going to put some safety on your firmware. So in a way, if you don't mess up, that is by sending to your untrustworthy Chinese manufacturer the firmware that he actually needs to put on the board in clear and something like this, which actually does happen quite often, you should be safe from that point. More or less, you can keep that firmware in-house, so they will really need to replicate it by hand, which of course is feasible, but I mean, even in China, that we are talking about 2 or 3 months of delay on putting the product on the market. Then if we talk about more the end user software, and what we talk about the apps, about all the framework, I mean, what basically is the interaction for the end user. I mean, it's your own UX. Of course, they can duplicate it. They can make something similar. And here there's not much we can do from our side. In any case, that's not where we see the value in the product. We outsource our UX, we outsource the development of the app, because for us, there is not really value in that. We prefer to keep the actual chain of developing the wearable itself and the algorithms, because that's where the value is. We know that if a copycat comes in, it will have not only to replicate the hardware, all the connection, all the textile, it will also have to do the firmware, and it will also have to try to understand how algorithm can make something out of that. And that last part, that's where our IP actually makes sense. We know that algorithm thing like this, to enforce it is always fun, not to say extremely tricky. On the other hand, I mean, it's a nice pattern to have, that's for sure. But just to replicate it, I mean, whether we just release it as a pattern or we keep it a trade secret, that postpone a little bit the work of copycats. So if we are a success, that give us a few months more to actually build a brand and everything that actually makes sense to remain the market leaders.
Great, thank you. Super cool, super good insights. Final question to both of you. If you think back yourself, like 2-5 years ago, I don't know, maybe when you just started, and you could give yourself one advice, traveling back in time or something, leaving a note somewhere in your previous me. So what would it be? It doesn't have to be about prototyping, but something business related with your business. Or, yeah.
I mean, from my side, I'm an engineer at heart, and what I never expected is that it would be that hard to actually build it. I mean, I thought our device was kind of simple to put everything together. It's way, way, way harder. It's what we're doing is a very, very complex product, and I never thought it would be that complex. So our development time, I'm not talking about doubling. We're talking about almost between quadruple, 5 times what it was supposed to be. It's massive. It's very complex products. I don't know, Leo, what you would say. But...
So maybe for the entrepreneurs out there, keep it simple.
Right. So in my case, I would say, get the products into the hands of the users as soon as possible, faster than you think. That would be my advice because it's kind of like the only way for you to actually learn into making it better. And yeah, we had to learn this the hardware. Like once getting it out there, like the final manufacturer injection molded product, we had to go through processes in order to fix some mistakes there as well. And so yeah, it doesn't matter what product you do, get it out there into the hands of the users quicker. I would say that to myself.